There's a blood-red Goliath. VIP looking forward to you, put it where the sun is. It could release as much as the circle of Jupiter. It's far-reaching, totally delicate, and going to detonate. Those effects are a portion of the most critical launches of radio energy inside the entire universe, giving over more energy than 1 billion suns. Are you prepared for what will occur? A sickening minimal creature squeezes a colossal red savage star, one of the nearest stars to Earth. It has truly gone through a striking lessening, standing out and blending feelings. By and large, this reduction has prompted speculation among stargazers and the general public about its true potential repercussions. Numerous investigators accept that the peculiar lead may be a harbinger of an incalculable impact, an unpleasant event that happens when a star depletes its nuclear fuel and collapses under its own weight. A huge impact like this raises concerns, not just among established scientists, but also among the general public, as it increases questions about the potential influence on our own planet. Noxious Betelgeuse is a conspicuous part of the Orion constellation, easily recognizable in the night sky due to its unmistakable structure and bright stars. Otherwise known as Alpha Orionis, it holds the title of one of the most glorious and greatest stars in the celestial sphere. Persistent data collected by NASA's Hubble Space Telescope, along with observations from various observatories, have shown that Betelgeuse experienced an enormous mass ejection in 2019. This event is uncommon for a star of its kind and has intrigued astronomers. While coronal mass ejections are normal for our Sun, the extraordinary event seen in Betelgeuse adds a fascinating layer to our understanding of stellar life cycles and the dynamics of massive stars. The distance to Betelgeuse remains a topic of discussion among astronomers. Some estimates suggest it is farther away, while others believe it could be as close as 724 light-years from Earth. Determining the distances of red giant stars like Betelgeuse is a complex task due to their immense size and variable luminosity. Betelgeuse stands out as one of the most magnificent stars visible in our night sky, shining many times brighter than the sun. However, this immense brilliance comes at a great cost. Betelgeuse burns through its nuclear fuel at an accelerated rate, racing toward the inevitable end of its stellar life. Eventually, this massive star will exhaust its fuel supply, leading to a dramatic collapse under its own gravitational pull, likely resulting in a supernova. This explosion could leave behind a neutron star or even a black hole, assuming our current astrophysical models hold true. This raises a significant question. Does Betelgeuse pose a threat to Earth? If a supernova were to occur just a few hundred light-years away from our planet, the consequences could be catastrophic. The explosion of a massive star can release an unimaginable amount of energy, potentially rivaling the brightness of an entire galaxy. The last recorded supernova in our own Milky Way occurred in 1604, and humanity has yet to witness such an event up close. However, a great supernova was observed in 1987 in the Large Magellanic Cloud, approximately 169,000 light-years away. While that event had significant scientific implications, it posed no immediate danger to Earth. The idea of a danger zone related to a nearby supernova is intriguing and could have severe consequences for life on our planet. If a supernova were to occur close to Earth, the high-energy radiation it emits could pose serious risks. However, it is important to note that in the grand cosmic timeline, supernovae are relatively minor events compared to gamma-ray bursts, which are far more powerful and present a greater potential hazard. Gamma-ray bursts can have devastating effects, capable of stripping away planetary atmospheres and exposing biospheres to lethal radiation. For example, a sufficiently intense burst could destroy a planet's ozone layer, leaving it vulnerable to harmful cosmic radiation. Even long after the event, lingering radiation could continue to threaten life. This possibility was highlighted in a recent study that introduced new potential risks associated with massive stars at the end of their life cycle. When enormous stars explode in a supernova, they can become some of the brightest objects in the universe. In fact, the brightness of a single supernova can surpass the combined luminosity of millions of stars. This brings up an important question. What would happen if Betelgeuse were to undergo such an explosion? If Betelgeuse were to go supernova, it could become the second brightest object in our sky after the sun regardless of its distance from Earth. It would shine brighter than a full moon and could even be visible during the day. The sheer energy of the explosion might create a display so dazzling that shadows could be cast even in complete darkness. Such a sight would both awe and terrify, revealing the raw power of cosmic events. While the visible light from a supernova is spectacular, it is only a small fraction of the total energy released. The greater concern lies in the high-energy radiation emitted alongside the visible light. This radiation, primarily in the form of X-rays and gamma rays, can have widespread effects. One of the primary dangers posed by this radiation is its ability to deplete the ozone layer, which protects our planet from harmful solar radiation. Without a stable ozone layer, life on Earth would be exposed to extreme ultraviolet radiation from the sun, potentially leading to mass extinction events. In the aftermath of a supernova, additional hazards arise over time. In the initial moments following the explosion, intense radiation presents an immediate threat. However, as time passes, powerful beams of energy and debris traveling at near-light speeds begin to move through the solar system. These energetic particles can further erode the ozone layer and blanket Earth's surface with harmful radiation, worsening the risks posed by the initial explosion. Moreover, supernovae release a significant portion of their energy as cosmic rays, high-energy particles that can penetrate deep into space. These particles can have lasting effects on planetary atmospheres and biological systems. Beyond the immediate radiation threats, a supernova explosion can also impact the interstellar environment in profound ways. The shock waves generated by such an event can trigger the formation of new stars by compressing nearby clouds of gas and dust. This means that while a supernova is a cataclysmic end for one star, it can also mark the beginning of new stellar systems. However, for planets in the vicinity, the impact of such an explosion can be devastating. If Earth were close enough to Betelgeuse when it went supernova, the intense radiation and high-energy particles could disrupt our planet's magnetosphere, potentially stripping away portions of the atmosphere and exposing life to deadly cosmic rays. Thankfully, scientists believe that Betelgeuse is far enough away, around 600 to 700 light-years, that even if it were to explode, it would not pose an existential threat to Earth. The primary effect we would experience would be an extraordinary light show, lasting for weeks or even months, as the dying star outshines almost everything else in the night sky. Yet, the question remains, when will Betelgeuse explode? Astronomers estimate that Betelgeuse is nearing the final stages of its life. However, predicting exactly when a supernova will occur is incredibly difficult. While its recent dimming event in 2019 led some to speculate that an explosion was imminent, further observation suggests that Betelgeuse is still stable, for now. The star's unpredictable fluctuations in brightness are likely due to surface activity, dust ejections, or convective processes occurring within its outer layers. While these signs indicate that Betelgeuse is approaching its end, they do not provide a precise timeline. The explosion could happen within the next few thousand years, or it might have already occurred, with the light from the supernova still traveling toward us. When it does finally explode, Betelgeuse will transition into either a neutron star or a black hole, depending on its exact mass. If it forms a neutron star, it will become an incredibly dense, fast-spinning remnant with an intense magnetic field. If it collapses into a black hole, it will vanish from sight, leaving only its gravitational influence behind. For now, Betelgeuse remains a fascinating object of study, providing astronomers with valuable insights into the life cycles of massive stars. The ongoing observations by telescopes around the world, including NASA's Hubble Space Telescope and ground-based observatories, continue to monitor its activity, searching for clues about when the inevitable explosion will take place. In the grand scheme of the universe, supernovae, like Betelgeuse's eventual explosion, play a critical role in cosmic evolution. They enrich the surrounding space with heavy elements, seeding the galaxy with the raw materials needed for the formation of planets and, ultimately, life itself. While the potential for destruction is significant, supernovae also remind us of the vast, dynamic nature of the cosmos, where endings give rise to new beginnings. Until that fateful day arrives, we can only watch, wait, and marvel at the universe's grand design. Their drawn-out impacts can endure for hundreds of years. There is proof suggesting that such occasions might have impacted Earth in the past. For instance, raised levels of iron-60, a radioactive isotope made in supernovae, have been tracked down in sea floor residue and lunar regolith. This finding demonstrates that Earth might have been affected by cosmic explosion ejecta in late geological history, conceivably within the past few million years. Stargazers have proactively inferred that there are no nearby cosmic explosion competitors that represent an approaching risk to life on Earth. In view of our ongoing understanding of the dangers associated with gamma rays and supernovae, however, progressing research has revealed additional expected risks connected with explicit types of supernovae. These supernovae can deliver long-range, deadly radiation that poses an additional threat to planets like our own. The system behind this involves a star approaching the finish of its life, encircled by a huge disk of material. When the cosmic explosion happens, a shock wave is created, hitting this disk and making it become incredibly hot, releasing a huge amount of high-energy X-ray radiation that can travel impressive distances through space. The most brilliant X-ray cosmic blasts have the capacity to deplete a planet's ozone layer by as much as 50%, creating conditions that could lead to an extinction event within a range of around 150 light-years. Luckily, no candidate X-ray cosmic explosions have been identified in Earth's immediate vicinity. However, this research has led to new insights into the concept of the habitable zone in space, the region within galaxies where conditions are suitable for life. The findings suggest that this habitable zone may be subject to more constraints than previously thought. Specifically, the outer regions of galaxies may not have sufficient star formation activity to create the elements necessary for the development of rocky planets. Meanwhile, the inner regions, where stars form and die at a faster rate, present their own risks. Frequent supernovae in these regions can illuminate the surrounding space, increasing the dangers for any potential life that might exist there. New studies show that the inner boundary of the cosmic habitable zone is likely located farther from the galactic center than previously believed, reshaping our understanding of where life may potentially flourish. So, what might the alarming celestial event of a supernova look like from Earth? While Earth's biosphere will likely remain unaffected, the actual display will be difficult to ignore. According to scientists, the supernova will continue to shine brightly for more than 90 days following its explosion, achieving a brightness nearly half that of the moon on various occasions, though much fainter than a full moon. Essentially, it will appear as a bright point above, serving as a beacon that could be visible even during the day. Its striking brilliance will captivate everyone who gazes at it, casting colored shadows at night. This celestial event will undoubtedly be a source of fascination for people on Earth, as the cosmic explosion remains visible to the naked eye for months. Its remnants will gradually fade as researchers continue to study the event, revealing more about the life cycle of massive stars and the processes that lead to their explosive endings. Understanding these immense phenomena is essential for gaining insights into the evolution of our universe and the formation of elements during a supernova. Moreover, the light produced during these events contains many heavy elements, such as gold, silver, and uranium, which are formed under the extreme heat and pressure of the explosion. This process, known as nucleosynthesis, plays a key role in enriching the interstellar medium with the building blocks necessary for future star and planet formation. Interestingly, the remnants of a supernova, known as a supernova remnant, can become a stellar nursery where new stars are born from the dust and gas ejected during the explosion. This recurring cycle highlights the interconnectedness of cosmic activities and demonstrates how the death of one star can lead to the birth of others. Scientists have identified several supernova remnants that are still forming new stars years after the original explosion, showcasing the dynamic nature of the universe. Another fascinating aspect of studying supernovae is their role as cosmic distance markers. Cosmologists use type Ia supernovae, explosions from white dwarf stars that reach peak brightness, as standard candles for measuring distances in the universe. By analyzing type Ia supernovae, astronomers can determine distances to faraway galaxies with remarkable precision. Since these explosions produce a consistent peak luminosity, they serve as reliable standard candles, allowing scientists to measure the universe's expansion rate. This research played a crucial role in the discovery of dark energy, the mysterious force driving the accelerated expansion of the cosmos. Supernovae also contribute to the overall chemical enrichment of galaxies. When massive stars explode, they release vast amounts of heavy elements, such as iron, nickel, and calcium, which eventually become part of the interstellar medium. Over time, these elements are incorporated into new generations of stars and planets, making supernovae a fundamental process in the cosmic cycle of matter. In fact, many of the atoms in our bodies, such as the iron in our blood and the calcium in our bones, were forged in the fiery deaths of ancient stars billions of years ago. Beyond their scientific significance, supernovae have also been observed and recorded throughout human history. Some of the brightest supernovae, such as SN 1006 and SN 1054, were visible during the day and left behind famous remnants like the Crab Nebula. Ancient civilizations, including the Chinese, Arabic, and indigenous astronomers, documented these celestial events, recognizing their profound impact on the night sky. Today, modern telescopes continue to search for and study supernovae in distant galaxies, helping to refine our understanding of stellar evolution and cosmic phenomena. Looking to the future, advancements in astronomical technology, such as the James Webb Space Telescope and next-generation observatories, will enable scientists to detect supernovae with unprecedented detail. These discoveries will shed light on the final moments of massive stars, the mechanisms driving cosmic explosions, and the role of supernovae in shaping galaxies across billions of years. As we gaze into the night sky, we are witnessing the echoes of past supernovae, remnants of stellar deaths that helped create the universe we know today. While the potential risks of nearby supernovae are minimal, their beauty and significance remain a testament to the vast, dynamic, and ever-evolving cosmos.